In this module, we turn theory into concrete choices. You'll learn how to pick between NVIDIA GPUs, Google TPUs, and Huawei Ascend NPUs for real ML projects, balancing cost, performance, and complexity for training, fine-tuning, and large-scale inference. When you pick H100, TPU, or Ascend, you're not just choosing a chip. You're buying into an entire stack that runs from hardware all the way up to deployment. At the bottom, interconnects control how well multiple chips talk to each other, which directly affects large model scaling. On top of that, sit compilers, which decide what optimizations are even possible. Framework support then shapes your day-to-day life, which libraries you can use, which tutorials actually work, and how painful debugging becomes. Finally, deployment options define where you can run production workloads, multi-cloud, single cloud, or mostly within one vendor's ecosystem. So every hardware choice is also an ecosystem commitment. Keep that in mind throughout this module. It helps to think of these three accelerators as different personalities. NVIDIA H100 and H200 are the all-rounders. They run almost anything, have the richest open-source ecosystem, and fit into many clouds or on-prem clusters. If you want maximum flexibility and community support, you usually start here. Google Cloud TPUs are specialists. They're tightly optimized for large, dense tensor workloads compiled with XLA, and they really shine when you're all in on TensorFlow or JAX at massive scale. But they live only inside Google Cloud. Huawei Ascend focuses on efficient AI cores with deep MindSpore integration and strong regional deployment options, especially where local infrastructure or regulation favors that ecosystem. Now, apply that to a concrete case. Training models like ResNet or YOLO on ImageNet may be across 1 to 8 accelerators. For this kind of moderate-scale vision work, NVIDIA H100 or H200 is usually the default. You get fast iteration, excellent PyTorch support, and a huge pool of examples and tutorials. If your pipeline already runs on Google Cloud, TPUs can deliver higher raw throughput per dollar, especially at large batch sizes. Ascend becomes attractive when you're in a Huawei-focused region or ecosystem. With MindSpore and local support, it can be the most cost-efficient option. As you scale large language models, raw compute isn't usually the first thing that breaks. The real pressure points are memory capacity and the bandwidth between chips. Three components dominate memory for big transformers. First, parameter weights, which can easily reach tens or hundreds of billions. Second, optimizer states during training, which often triple or quadruple the total footprint. And third, the key value cache used during inference, which grows with sequence length and batch size. All of this has to fit on a single device, like an H100 or Ascend 910C, or be split across multiple devices. Once you split, interconnect bandwidth and latency become your new hard limits. For large language models in the 7 to 70 billion parameter range, you're really choosing between three philosophies. NVIDIA is the frontier default. Huge HBM capacity on H200, excellent throughput, and a mature stack around DeepSpeed, Megatron, and FSDP. If you need maximum flexibility and ecosystem depth, this is usually the first pick. Google TPUs shine when you fully buy into JAX or TensorFlow with XLA on Google Cloud. At massive scale, their cost per token trained can be extremely compelling, but they're less forgiving outside that workflow. Huawei Ascend can deliver strong performance in tightly integrated Huawei clusters, though ecosystem breadth and portability still lag behind the other two. Low latency inference is what matters when users are waiting in real time. Recommendations, chat, search, fraud checks. Here, the key levers are tail latency, throughput, and cost per query. NVIDIA GPUs usually win on flexibility. TensorRT, Triton, and modern LLM serving stacks give you fine control over dynamic batching and P99 latency, plus mature observability. TPUs work well when you can keep them busy with large batch inference, especially if the models were already trained on TPUs. Ascend performs well for vision and NLP once you compile models ahead of time and keep workloads relatively stable. Moving from CUDA GPUs to TPUs or Ascend isn't a simple flip of a switch. First, you translate code. That might mean moving PyTorch to JAX or MindSpore and replacing any custom CUDA kernels with framework native ops or vendor libraries. Next, you make the model itself portable. Export to OnNex or saved model, Then re-import so graph structure and supported operators align with the new hardware. Then you update operations. CI/CD pipelines, monitoring, logging, and auto-scaling all need to understand and target the new devices. After each migration step, recheck numerics, operator coverage, and performance scaling before you trust results in production. The key idea is to start from your architectural reality, then let hardware follow. Ask first, what is the one constraint you cannot easily change? If it's flexibility, heavy PyTorch usage, or a mix of on-prem and multiple clouds, NVIDIA H100 or H200 is usually the safest bet. If you're already all in on Google Cloud using JAX or TensorFlow and care most about large-scale training efficiency, TPUs tend to win. If you work in regions or sectors where Huawei infrastructure is standard or required, Ascend becomes the natural anchor. Once that primary constraint is clear, you fine-tune for cost, scale, and latency, but the field is already narrowed. In the end, choosing hardware is about matching your constraints, not chasing a single best chip. For moderate-scale vision work, NVIDIA is often the smoothest path. Strong libraries, abundant examples, and easy hiring. TPUs shine when you already live in the Google ecosystem and want high throughput with managed infrastructure. Ascend can be compelling where cost, power efficiency, or regional availability matter more than tooling polish. For LLM training, H100s or H200 and modern TPUs lead on maturity and scale, while Ascend is emerging but more niche. For low latency inference, GPUs and Ascend both work well on-prem, and TPUs are compelling for large, steady cloud workloads. Start from workload, ecosystem, and operations, and let those drive your accelerator choice.